Hello, my name is Jordy Abdul, and today we're going to talk about fractions. I talk about fraction because I really want you to understand the concept. To do that, you must write down what I write and practice afterwards. So, what is a fraction? A fraction is the number of parts you have divided by the total number of parts. So, if I have a pizza cut into 4 parts and I ate 3 pieces, what fraction of the pizza did I eat? Okay, so let's draw a pizza here that will be cut into 4 pieces. So, if I have a pizza cut into 4 pieces, and I ate 3 pieces, what fraction of the pizza did I eat? I ate 3. The number of pieces that I ate divided by 4, the total number of pieces, which is 3/4. So I ate 3/4 of the pizza. Caution, the pieces must be cut equally. You have to make it cut equally in order for it to be a fraction. This is one of what's called benchmark fractions. Benchmark fractions are fractions that are easy to understand and have small numerators, the top of the fraction, and small denominators, the bottom of the fraction. But they are not types of fractions, however. Fractions such as proper, like the benchmark fraction we have here, it is a proper fraction. Improper, whole, mixed fractions are all different types of fractions. Proper fractions are fractions that have the numerator less than the denominator. Like I said before, this benchmark fraction is a proper fraction because the numerator 3 is less than the denominator 4. So let's take 3 examples. 3/4, 5/6, and what's very common, 1/2. Improper fractions are fractions that have the numerator greater than the denominator. So it's the opposite of proper fractions. So this will be such as 4/3, 6/5, and 7/6. These are all improper fractions. Whole fractions are fractions that equal whole numbers. So that means what? This means that the numerator divided by the denominator will be a whole number. For example, if we have 3/1, if we divide 3 divided by 1 is 3. 2 divided by 2, which is 1, or 8 divided by 4. Now, when you divide the numerator by the denominator, you will get a whole number. Technically, whole numbers are improper, but they make more wholes. But improper fractions do not make wholes. There is a leftover. So, an example of improper, 4/3. Now, that doesn't make another whole. However, whole numbers, when you divide the numerator by denominator, you will get a whole number. That's the difference. Mixed numbers are numbers that consist of whole numbers and fractions. Proper fractions, to be exact. Mixed numbers and improper fractions are similar and can be converted to one another. But we will talk about this later in this video. So examples of mixed numbers, like I said earlier, have whole numbers, not whole fractions, but whole numbers, plus a proper fraction. So let's say we have 3 plus 1/2, or just 3 and 1/2. Remember, these are adding. We also have 4 and 5/6, or 5 and 2/3. These are all mixed numbers because they have whole numbers plus proper fraction. So these are all the types of fractions. Now we will move on to something else. Sometimes we have a large fraction and want to make them smaller, not in size, but in large numerators and denominators. So if we have 2 rectangles cut into 4 and the other one cut into 2, we will then shade 2 in the first rectangle and 1 in the second rectangle. Notice that they are shaded in the same amount. As we can see here, they are shaded in the same amount. And remember, they have equal area and perimeter and same orientation, which means that it's horizontal, not vertical. So this means that if we named these rectangles A and B, that means A equals B, whether we're talking about perimeter or area. And A is 2/4, according to here. Our fraction for A is 2/4, to make it clear. B is 1/2. So if A equals B, that means 2/4 equals 1/2. So let's test this algebraically, using math instead of graphs like these rectangles. Let's take factors of the fraction that rectangles A and B have to get our original. And to take factors of something means to multiply 2 numbers together to get our original number. Of 2 and 4, which is the numerator and denominator of our fraction of rectangle A, because they have something in common. So take the GCF, greatest common factor of them. Okay, so if we have 2/4, and we're trying to find the factors here. So we have 1, because every number must have a factor of 1, which makes 2 prime because a prime number means to have 2 factors, and 2 here has 2 factors, which means 2 is a prime number. Now let's find the factors of 4. So we have 1, 2, and 4. Now we have to find the greatest common factor. So usually we would have more than one factor here. That's why we want to divide by the greatest factor to get the fraction into simplest form. But we only have one common factor here. Well, technically 2, but because 1 doesn't do anything to the fraction, we shouldn't consider it. So we have here 2. So this fraction would be the same as 2 divided by 2 over 4 divided by 2. Remember, this is the same fraction because we are dividing the numerator and denominator by 2. So we're dividing by 2 over 2, which is divided by 1, which, like I said earlier, doesn't do anything. So we get 2 divided by 2 is 1 in the numerator, and 4 divided by 2 is 2. What do you notice here? That once we simplified, we see that 2/4 really is 1/2 algebraically. And remember, this is a verification. So we just verified. So we know both ways that graphically 2/4 equals 1/2 and 2/4 equals 1/2 algebraically, both ways. Now finally, let's start converting mixed numbers and improper fractions, because it will be good to know before we talk about adding and subtracting fractions. So to do that, let's talk about converting improper to mixed, because improper we want to convert to mixed fraction in the first place. So let's start with that. So to do that, let's take an example. Let's say 15 over 6. What we do is we ask, how many times does 6 go into 15? Well, we know 6 times 2 equals 12, and 6 times 3 equals 18. So the answer is 2, and we know 6 times 2 equals 12. So take the difference. We take the difference between 15 and 12. So we have 12, and then we add the difference between 15 and 12, so we get 12 plus 3 over 6. So this is what we get. Now this works out because in the numerator I have 12 plus 3, which is 15 over 6. Okay, equals. So we divide every number in the numerator by 6. So we get 12 divided by 6 plus 3 over 6. So I get 2 plus 3 over 6 equals 2 and 3 over 6. Now, don't you notice something with the proper fraction here? Well, 3/6 here is not in simplest form, so we can simplify it. So let's put the 2 aside for now. So let's just write it here, and then we get 3/6. So what's the greatest common GCF here? So, well, I know it's 3. I'm just going through this quick, but I want you guys to take the factors of 3 and 6 and find the simplest form. So we have 2 plus 3 divided by 3 over 6 divided by 3, which is 2 plus 1/2, okay, equals 2 and 1/2. Okay, so doesn't that make you think about something? Well, I notice here that that we're simplifying at the end. Doesn't that mean that we could simplify in the beginning? Yes, we can. So this means that we can also simplify improper fractions also, because it's just like a regular, because it's still a fraction, right? So we can still simplify it. Okay, so let's do this another way. So let's simplify 15 over 6. Now, since we know the GCF at the end was 3, we know that the GCF in the beginning was 3. Once again, I want you to find the common factors of 15 and 6. So we get 15 divided by 3 over 6 divided by 3 equals 5 over 2. How many times does 2 fit into 5? Well, it's 2 times. And we add the difference between 5 and 2 times 2, which is 4. So we have 4 plus 1 over 2 equals 2 and 1/2. So we got the same answer as before. But instead we had to simplify in the beginning instead of simplifying in the end. So it is better to always simplify first. You have to think, can the fraction be simplified or not? Okay, now let's do the other way around. So let's start off with mixed number. So we have 2 and 1/2, and we are trying to turn it into 5 over 2. So we're going to multiply the whole number in the denominator and then add it to 1. So why are we doing this? Well, okay, think about this. 2. We know that's a whole fraction, right? So with the denominator of 2, what would be our numerator? So this would be 4 over 2, because 4 over 2 is 2 plus 1 over 2, which is the same thing as 2 times 2 plus 1 over 2, which is exactly what I'm doing here. So if we continue on with this, we get 4 plus 1 over 2 equals 5 over 2, which is the same thing we got from before. Okay, that will be it for the video. Thank you so much for watching. Subscribe, hit that notification button, hit that like button, and also I will tell you this. This will be a series about many types of fractions in later videos. So we need to talk about comparing, adding, subtracting, multiplying, all that stuff. Practice all that if you have learned, because there will be a test on the last fraction video, so study for that. So, bye. See you on my next video.